In Section 8 of Chapter 5, we're going to be working with formulas. Sometimes we'll be substituting, sometimes we'll be solving a formula for a letter, one of our important skills. So these are our objectives. And keep in mind that as you put letters into your Hawks program, be sure if it calls for capital A, you put a capital A. If it's lowercase r, put lowercase r, because the uppercase and lowercase letters could mean something different. And in example 1, we're going to evaluate formulas, and we're going to take a look at what is called simple interest. Now, the formula for simple interest, and you should write this in your notes, is capital I equals principal times the rate times the time. And this is what's laid out here. And if you're not familiar with any of these, you should write these terms. Now, Maribel loaned $5,000 to a friend for 3 months at an annual interest rate of 8%. How much will her friend pay her back at the end of 3 months? So they're going to lay this out for us, but I'll do a little bit of it here as well. So the formula is interest equals the principal times the rate times the time. So we don't know what the interest will be. We know the principal is $5,000. The rate is going to be 8%. And if it was just 1 year, it would be a 1 here. But now we have to put the months as if it were a year. So we could do that as 3 months out of 12 months. And we could have written that as 1/4 as well. So chances are you're going to put all of that into your calculator and calculate it. And we'll see what they do here. So there's what I had, and they are reducing it to 1/4. But again, since you're going to put it into the calculator, no big deal. You could do some cross-canceling. Again, no big deal. So you get that the interest would be $100. Now you would have to add this interest to the principal. So the amount that you would pay back is $5,100. Again, be sure you are answering the question they're asking. Okay, and here's a case where they give you a formula for finding Celsius, and it's 5/9, and then Fahrenheit minus 32. So they're giving you the Fahrenheit, and find F if we have the Celsius of 20. So let's take a look here. So we're going to substitute the 212 for our Fahrenheit, do the subtraction, we get 180, and then we could multiply that by 5 and then divide by 9, and that would give you 100. Now, that is 212 degrees Fahrenheit is the same as 100 degrees Celsius. Water boils at 212 or 100 Celsius. And that's at sea level, by the way. There needs to be a certain amount of pressure, the weight of the atmosphere at sea level. If you get higher elevations, water boils at sometimes 190, depending on atmospheric pressure. A little bit of science thrown in there. So now we're going to substitute 20 into the formula. There we put the 20. And we want to solve for F. Well, they want to isolate the F on this side, so they're multiplying the fraction here by its reciprocal. So this just becomes a 1 on this side. And then when you take 5 into 20 is 4. 4 times 9 is 36. So now if we subtract, or I should say add 32 here, that makes this a 0, and we add 32 there. That's what they're doing. Your Fahrenheit, when the Celsius is 20 degrees, is 68. So these are pretty much the steps I would have written and a way to do it. Now in this case, they're talking about the lifting force, F, exerted on an airplane's wing is found by multiplying some constant K by the area of the wing's surface, which is the A, and the square of the plane's velocity. That is how fast the plane is going, that we're going to square, as we said. Find the force on a plane's wing during takeoff. If the area of the wing is this, K is this, and the plane is traveling at 80 miles per hour. So we're just going to substitute all of this into this formula. They're giving you a nice little picture here. And when you do, you get this. So you're just substituting. Now the question is, what do you do first? Well, in the order of operations, we're going to square the velocity first. Don't do this multiplication, you do this. And that's 6,400. And you could, if you're doing arithmetic, you can just do some canceling here, but we're not. Just putting all this in the calculator. 4 times this, divided by 3. And you want to practice this on your calculator. And it gives you 1,024,000 pounds is the force that pushes up the plane. Wow, that's what gets it to fly and get off the ground. Wow. Now again, you want to have this worked out in your notes. So if that's a quiz question, you know the answer. Now I may give you this information, but you'll need to know the process, or if you have it written out, you'll have it right there. Okay, here we have the perimeter of a triangle is this. One side is 5 feet long, the other side is 18 feet long. How long is the third side? Well, we often mention that if you do a little diagram, that helps. Your total perimeter is this. One side is 5, one side is 18. We want to find side C. So this is the perimeter formula. So if we add these two together, and that'll give us 23. So 23 plus C equals 38. We're just going to subtract 23 from both sides, and that will give us our third side, which is 15. So I don't know if you're familiar with the perimeter formula of a triangle. It's pretty straightforward. If you were an ant crawling around the edge, that would be the perimeter, and then it would be the sum of the three sides. Okay, solving for different variables. Now, for this, we're going to use the principles we've worked on. The basic formula for distance is distance equals rate times time. Now remember, this is multiplication. We don't put a dot there, but that's what it is. And they want us to solve for t. So what does t equal? Well, think of t as the variable and r as the numerical coefficient. How do we isolate the t? Well, we divide by the numerical coefficient both sides. So here the r's cancel out and we're left with t equals distance divided by rate. Again, have this in your notes if it were a quiz question. And there it is. Okay. And I'll do these because I like these. And I like everything actually, but okay. We want to solve for the letter P, and our formula is capital V, lowercase a, and this looks like a P. Well, I don't know if it's capital or not. Maybe it's lowercase. Now, we want to solve for P. So, this is sort of like a fraction here. We said to get rid of fractions, multiply by the lowest common denominator, and our denominator here is P. So if we multiply this side by P, and this side by P, here the P's cancel out, and we get P V equals K. But we want to solve for P. So how do we isolate our P here? Well, again, this is P times V. So if we divide both sides by V, here the V's cancel out and we get P equals K over V. So let's check it out here. Again, you want to eliminate the fraction P by multiplying both sides by P, and then you want to divide both sides by V to isolate the P, and there is your answer. Okay, here we're asked to, we did some of these earlier, but we want to just solve now for the letter F, as opposed to, let's just write it out. So we have C equals 5/9 F minus 32. You want to write this in your notes. Now, to start to isolate the F, we're going to get rid of this fraction by multiplying it by its reciprocal, 9/5, and this by the reciprocal, 9/5. So here, this is all going to cancel out, and to save a little bit of room, I'll just erase all this. And I can also erase the parentheses now, because I don't need them anymore. So I want to solve for F. So I move the equal sign over there a little bit. I'm going to just transpose this to the other side, where on this side it becomes plus 32. And I'll use my eraser again. And you see how it was done. And there's the answer. So we have solved this equation, this formula for the letter F, by using techniques of solving an equation. All right, let's see what they come up with. Using the reciprocal, getting rid of the parentheses, and then adding 32 to both sides, or just transposing that, and you get this. Well done. That's what we did. Okay. Now, here they want us to solve this equation for x in terms of y, and then later we'll solve it for y in terms of x. So this is going to be a rather famous equation that we're going to use in our next chapter as we start to do some graphing work. This is a standard form of the linear equation in two variables, x and y. So we want to solve for x first. So let's put that over here. 2x plus 4y equals 10. Now let's see how much of our techniques we remember here. We're going to transpose that so we get 2x. Now on this side it becomes a negative 4y plus 10. And I don't know why I wrote a 2 there. And now we're going to divide each term by 2. Now we could put this all over 2, but you'll see why we do it this way. So this is x equals a negative 2y plus 5. So we have solved this equation for the letter x. Now let's solve it for y. 2x plus 4y equals 10. Again, we're going to transpose the 2x. Negative on this side, 2x plus 10. And now we divide everything by 4. And we get y equals a negative, I'm simplifying this to 1/2, plus, take a 2 out of each one, 5/2. So here we've solved it for x, here we've solved it for y. And we can see what the book is going to do here. And they show that you can put it all over 2, but the better way is this way, and then you simplify and get this as our answer. Okay. Now for y. Again, they're using this horizontal thing. I'm not sure why they're not introducing transposition, because by this time that should be a common way to move a term from one side of the equation to the other. And then you simplify, and there you get it. Now you could write it this way, but this is the preferred way, as you will see, because now in our next chapter this is slope-intercept form, where this is going to be your slope and this is your y-intercept, but MATLAB or the software should accept both here. Okay, let's do this one. We want to solve for y now. This is in standard form. We want to solve for y. And we can look for any shortcut too. Now we want our y to be positive. So I would just take this y, move it to this side where it becomes positive, And then take this 15 and move it to this side where it becomes negative. And there we have solved it for y. Now again, we usually read it y equals 3x minus 15. Now they're ending up with a negative y, so they'll have to divide by a negative 1 to change, or multiply by a negative 1 to change all their signs. So you see the way we did it, I think a little bit better, but again, there's other ways to do it, and as long as you get the correct answer. And now for some practice problems, and we have a little time, so why don't you work those out, and then we'll show you the answers in a few moments. Let's pause. So this one is rather easy to do. We just transpose the y and transpose the 5. Here we transpose the y and then divided everything by 2. And I'd like to do this one with you because we didn't do this one, or one like it, and you're going to have some of this in your homework here. We want to solve for the letter h. So again, there's fractions. First thing I do is get rid of that fraction by multiplying both sides by 2. So the 2's then on this side cancel out, and I can erase them now. And then you want to solve for h. So all you do now is divide both sides by b. And h equals 2a over b. So the key here, divide both sides, or multiply both sides by 2 here. So they get to cancel out. And to solve this one for r, we have L equals 2 pi RH. Well, these are all 2 times pi times r times h. These are all factors. So to cancel out factors, we just divide by them. 2 pi h. 2 pi h. This cancels out, this cancels out, this cancels out. We're left with r equals L over 2 pi. Now for 5, we want to solve for w. So we have p equals 2 lengths plus 2 widths. We want to solve for a w. So the first thing we're going to do is isolate the w by bringing our 2L term over to the other side where it changes its sign. And then we just divide by 2. And we get w equals p minus 2L all over 2. Now, another way to write that would have been p minus 2L. 2L. Got carried away there again. And we're going to divide each term by 2. So we divide this by 2, divide this by 2, rather than putting it all over a common 2. And then here the 2's would cancel out, and you would get p over 2 minus L equals w. So this way is good, and this way is good. All right, that'll wrap this up here.